All right, we'll start with the general form of what a quadratic parabola looks like, a quadratic function. And we'll start with something very simple. The first thing that we're going to look at is something called the y-intercept. And the y-intercept is very easy to find because if you think about it on a graph, it is the place that crosses the y-axis. That's what the y-intercept means. Now, stick with me on this because I'm going to give you a real good plan as to how to find it. This point right here, let's call this 0, 1. Fair enough? This would be 0, 2, and this is 0, 7, and this point up here is 0, 10. This point down here is 0, -4, and 0, -8. You notice what's in common with all these points on the y-axis is the 0, right? The x value of all of these points on the y-axis are 0. So if you think about it, this ax squared term is going to be a 0 because the 0 for x cancels out. The 0 for x here cancels out, and I'm left with just the c value. So my y-intercept will always be found at 0, c, which is an excellent place to start when asking to graph a parabola. I take the constant, I take the c value, I find it, I say y-intercept is 0, that number right there, and I plot it down on the graph. Now, a little bit less obvious for all of us is how to find the vertex. The vertex is a little bit different. I'm going to give you a small formula to find the vertex. The x value is -b over 2a. And that's actually part of our quadratic formula if you've messed around with that in the past. And part of our quadratic formula is the x value is -b over 2a of where the vertex is located. So you change the sign of this and divide it by this number doubled. You change the sign of the b and you divide it by the a doubled. That's why it's 2a. How do you find the y value of the vertex? Well, you take your function and you evaluate it at said number. You take your f or your y, f of x and y are the same, right? You take your y or your function and you evaluate it at that number, -b over 2a. Looks complicated, it's not really that complicated. I'll show you how to find these values through an example. Okay? And these are the two things that you're going to need to know about how to graph a parabola. Let me give you the first example. Y equals 1/2 x squared plus 3. Y equals 1/2 x squared plus 3. Now, this one is a little bit different because I don't have a b value, but I do have a constant, and my constant in this case is what number? 3. So that means my y-intercept is found at 0, 3. So right away, I can take my graph, I can go up 3 units, and I can put a point right there. Fair enough? That's the easy part. I find the constant, I plot it. I find the constant is 0, c, I plot it. It's right there. If this number were minus, it would be down below the x-axis. Now, this one is going to be a special case because let's find the vertex. The vertex is found at -b over 2a. What is the b value? 0, right? So what this would be is -0 over something, and -0 is just really 0, and 0 over anything is really just 0. So my vertex is going to be at 0, something. But I already have a 0, something. I have a 0, 3. And to find out what this value is, let me just take 0 and plug it in. 0 squared is 0, and 0 times 1/2 is 0, and 0 plus 3 is just 3. Okay, this is confusing because my y-intercept is here. Well, wait a minute. My y-intercept and the vertex in this problem is the same point. Okay. Oh, we have a solution. Okay. What we need to do here, okay, I'm not going to require you to do this all the time, but if needed, in this case it is needed because I only have one point to deal with. If needed, we have to come up with a little chart, and I'm going to put 0, 3 in the middle. And if you recall from absolute value functions, okay, parabolas are symmetrical. And all I have to do is choose an easy number. I'm going to choose 1 and negative 1. A number on each side of the point that you have, in this case 0. Well, let's take 1 and plug it in. 1 squared is 1, and 1 times a half is a half, and a half plus 3 is 3 and a half. So there's my other point that I can use. And I said to you that parabolas are symmetrical. So if 1 gives me 3 and a half, negative 1 should also give me 3 and a half. And it does. If you don't believe me, check it. Now,
wouldn't it give you negative?
No, because when you take the negative 1 here and square it, becomes a positive 1. Okay? Watch what I'm going to do here. I'm going to take 1 and 3 and a half, and I'm going to plot it right here. Negative 1 and 3 and a half, and plot it right there. And I graph a nice, smooth, curved graph through your 3 points. Vance?
So up here where you find the vertex, when you go to find y, you take the x for the vertex, and that's 0, and you plug it up where it says y equals up there.
That's correct.
Okay.
That's exactly right. I want to look at another one just like this, and then we'll have one where your table is not needed. Okay? We'll do this one sort of quickly. Y equals negative 2x squared plus 7. Mr. Hilligoss, where is the y-intercept in this graph? 0, 7 is correct. Mr. Hilligoss, where is the vertex in this graph? It's a trick question, kind of.
0, 7.
That's correct, 0, 7. And I know that because the b value is 0. Listen to me. If your b value is 0, your vertex and y-intercept will be the same.
I was going to say, or your a value, but that's not possible.
Oh, that would make it linear, right?
Yeah.
These are the same because b is equal to 0. If your b is not 0, they're not going to be the same because your vertex is not going to be on the y-axis. All right, so what do we have to do here? These are the only 2 points I have to deal with. So let me take 0, 7. I'm going to choose 1 and negative 1 because those are easy. Vance, what's up? Go ahead.
Alright, so where it says vertex equals negative b over 2a,
Yes?
where would an a be?
The a would be the number in front of the x squared, also called the coefficient.
So negative 2?
That's correct.
So why did we do negative 2 divided by 2a?
Because on the top is negative b.
Oh,
b
okay, yeah.
is the number in front of the x, and I don't have an x.
Okay.
Mr. Wilkes?
Is it possible to have your y-intercept or vertex the same if you have a b value?
No. Great question. Now, let's take 1 and plug it in. What do we get here? Okay, keep going. Take 1 and plug it in. 1 squared is 1 times negative 2 is negative 2. Negative 2 plus 7 is 5. This should also be 5. Alright? So I got my 3 points. 1, 2, 3, 4, 5, 6, 7 is there. 1, 5 is here. Negative 1, 5 is there. And this parabola opens downwards, which you may notice has something to do with the a. Since my a is a negative number, your parabola will be inverted. It will be upside down. Here my a value was a positive 1/2. It was right side up. Now let me give you 1 or 2 that have a b value. And I want to graph them. I want to look at them. I want to try to find the vertex. Let's do x squared minus 4x plus 3. The first thing you do, right off the bat, without question, right away, immediately is find 0, c. My y-int in this case is found at 0, 3. I will give you a point for finding that and plotting it. And that, I'm afraid, is very elementary. The vertex is not very elementary. We have to find it. I have a b value in this case. My vertex is found at negative b over 2a. So that would be positive 4, because my b value is negative 4. My b value is the number in front of the x. You with me? Okay, positive 4 divided by 2 times 1. And that would be positive 4 over 2, or just 2. 2 comma something.
-1.
How do you find that something?
Negative v over 2a comma the function of
Negative b over 2a. That is, find your negative b over 2a, which we have right there, and then you take that number and plug it into finding. Because your vertex is found at 2 comma something, right? 2, where is it? Well, I take the 2 and plug it in. 2 squared is 4, minus 4 times 2 is 8, plus 3, and 4 minus 8 plus 3 is -1. And that's where my vertex is located. We'll do it again if that was kind of fast.
Yeah.
Now, all that we have to do is this. A table now is not needed. I have all the points that I need. Symmetry is going to help you in this case. Symmetry is your friend, because now I don't have to make a stupid t-chart, which I hate. If this is the vertex, I have a line of symmetry that goes down through the vertex. Would you agree?
Yes.
And if this point that I have as the y-intercept is 2 units away from that line, I have another point that is 2 units on the other side of that line. The point corresponding to it. Like last time we had a P and a P prime, and a Q and a Q prime. This is my y-intercept, and this point over here is my y-intercept prime. Do I have to make a table? No. I have all the points that I need. I got my vertex and 2 additional points, so I just graph through here and graph through there. And that's all that we need. Fair enough? Let's see if we have time for 2 more. That was f of x. Let's do g of x. G of x would be -1/4 x squared plus 2x minus 3. -1/4 x squared plus 2x minus 3. Your calculator is going to assist you. Oh, by the way, we should identify, and this is real simple, the AOS, or the axis of symmetry. And the axis of symmetry takes on the form of a vertical line. And the form of a vertical line takes on the form x equals a number. What is that number? 2. Because it's the x value of my vertex, x equals 2. And I just say that because the book asks you to find it sometimes. Okay. Where is my y-int? Well, this is simple. It is at 0, comma c, or 0, comma -3. Let's plot it. Now my vertex is a little bit more difficult. If you have a calculator, let's use it. My vertex is going to be at negative b over 2a is the key to your heart in this lesson. Negative b over 2a.